Hello, Dean Kershaw here, Kershaw Instrumentation. We're here today to talk about our Unwind tester model UT-60u. We're going to talk about some of the mechanical and the control features of this machine, and then we're going to actually run some samples and show you some of the features. For starters, I'm going to talk about the mechanical components that are on the front of the machine. This is our Unwind mandrel, which essentially is a mandrel mounted on bearings, and you can see it is designed so that it fits a 3-inch standard tape roll. This is the sensing roller here. The sensing roller is mounted on a load cell, so any force that's exerted on the sensing roll is going to be measured and by the load cell and recorded over here on our flat screen display. These two black rollers on the top, these are the drive rolls. They're knurled so that they provide adequate traction to pull the tape off of the roll. Finally, we have the wind-up roll, which essentially is a removable cardboard core, such as this one here, which we can take off by loosening this nut. But this is actually running faster than the drive rolls, so it's going to take up the slack at the end of the test. So let me show you how we actually load the sample. We're going to put the tape on the supply roll, and we're going to go under the sensing roll, over the drive rolls, and then we're going to wind up on our core. And you can see this is how the machine operates. Okay, now I want to talk about some of the controls on here. We're currently in the English mode, so our tension is expressed in ounces and our length is expressed in feet. We also have a metric mode where the tension is in grams and the length is in meters. This is where we can actually dial in what speed we want to run our test. I have it set right now for 50 feet per minute, but I could change that simply by touching that and entering my new value. The tape width. In this particular case, this is a 2-inch wide sample, so we want to set this to 2. And then what it's going to do, whatever the force is on this, it's going to divide by that 2 inches, and it's going to express our answer up here as force per inch. In this case, ounces per inch. Now over here, this is the torque. This is basically how much force is being exerted on this to wind this up. Not terribly critical. If you have heavy samples such as this, you may want to raise the torque. But if you have real lightweight samples, you want to keep that torque on the low side so you don't snap the wet. Another feature that we have 3 auto shut-off modes, and I'm going to explain those here. The first mode is what we call time shut off, and I have that set for 5 seconds, and that merely works like this. It runs for 5 seconds and it stops. Now at the conclusion of the test, we are displaying some parameters here, the min and the max and the average tension that was measured during the test, and also the length and where the maximum occurred on the roll. In our case here, our maximum force was a half a foot into the test. Also, this machine has a computer interface, which I don't have connected here today, but the computer interface will actually plot a curve that shows the force versus length. I think that's pretty self-explanatory. Now our second auto shut-off mode is our length shut-off, and I have it set for 10 feet. And we'll go ahead and run that. You'll notice this counting up, and it merely ran for 10 feet and shut off. That's pretty self-explanatory. Now our last auto test shut off is what we call a tension shut off. Now what we have here is, as we run the test, when our tension gets less than 2 ounces, like if we're at the end of the roll, this thing is going to automatically terminate the test. Well, if you think about it, when we start the test, if we have slack in the roll, this thing's going to shut off immediately. So we have what's called shut off inhibit, which I have set in this example to 1 foot. All of these numbers can be changed simply by touching the display. But I have my shut off inhibit set to 1 foot. Now, with what that means is that we're going to let at least 1 foot of material pay out of this thing before we're going to start looking at that tension value to shut it off. So that's going to let us have 1 foot of material to get the slack out so that we can run a meaningful test. And then at that point, when the tension goes under 2 ounces, as I have keyed in here now, it's going to shut off the test. Obviously, all this stuff can be changed at any time. So what I'm going to do is we're going to run a test, and I'm somehow going to make this thing go slack so that I can demonstrate how this auto shutoff works. So here we go. First of all, let's put some slack in the web. So you can see I have no tension on here at all at this point. So we have 1 foot for this thing to catch up, and then the automatic inhibit and the automatic shut off will kick in. So here we go. So you can see when I cut the web, our tension went to 0 and the test ended. There's one other feature on this machine that we're not going to demonstrate, but I will explain. We have what's called a speed inhibit, and the speed inhibit really only takes effect when you're running higher speeds. Now, this machine can go to 200 feet per minute. We were just running at 50 feet per minute, so this was relatively slow, the demonstration that I did here today. But at the higher speeds of 150 or 160, you may not want to see what's happening until this thing gets completely up to the operating speed. For example, if we turn this thing on at 150 feet a minute, it's going to take a certain amount of time in order for that to get up to speed. Well, what the speed inhibit will do is it essentially will ignore any data that's measured until this thing gets up to the operating speed, plus or minus whatever number we key in there. For example, if I run it at 150 and I make my my speed inhibit plus or minus 5 RPMs, or 5 feet per minute, what's going to happen is this thing's going to ramp up, but until it gets to 145 feet per minute, it's not going to start tallying any of the data. So enough about that. Now, one other thing I just want to show you is in terms of, we have a troubleshoot area in here, which we call the test panel. And in the test panel, essentially, we just have a live display of all of the I/O that's involved with this machine. And this is good for troubleshooting and for setup and calibration and so forth. There's really no need to go into this test panel unless you suspect that you have some type of a problem. But for example, I have the actual voltage coming out of the load cell, and if I squeeze that, it goes up. If I let it go, it goes down. Here's our calibrated tension, which essentially is our calibrated number. We have this button here. We can just jog the motor slowly to make sure that the motor is working properly. If you come up here, you'll see this indicator that's flashing red to green. That's the encoder inside, so that says that it's measuring the length properly and so forth. Right now, I have no tension on the clutch whatsoever, but if I hold this button, now I have pretty substantial torque on this clutch. So this is a way for us to be able to test to make sure that the clutch is working properly. Going back to our operating screen, the tests that we ran were in English, but we can also have all of those same features in metric. And like I said, the only difference is that it's expressed in grams and meters. So also there's a calibration section in here, which is password protected. And if we go in there, this is where we can do the load cell calibration. and the speed calibration. All of this stuff is done automatic. Essentially, we just enter the calibration section and it will walk us through the procedure for that particular feature. So that concludes our demonstration.